In this lecture, we take the eigenvalues or we find the eigenvalues and eigenvectors of the matrix whose order is 3. We have to find out the eigenvalues and eigenvectors of a matrix. A is equal to 8 minus 8 minus 2, 4 minus 3 minus 2, 3 minus 4, 1. Since the order of this matrix is C, 3, therefore the characteristic equation of A is given by lambda cube minus S1 lambda square plus S2 lambda minus determinant of A equal to 0. Where what is S1? S1 is nothing but the sum of diagonal elements of the given matrix, which is equal to 8 minus 3 plus 1. 8 plus minus 3 plus 1, which gives us 8 minus 3 is 5. 5 plus 1 is 6. So S1 is equal to 6. Similarly, what is the S2? S2 is nothing but the sum of minors of diagonal elements. Sum of minors of diagonal elements. So now what is the matrix? Let me just, this is the matrix 8 minus 2. So what is the minor of 8? Minor of 8 is leave this row and this column. So what is the remaining? Minus 3 minus 4 minus 2 1. This is what? It is the minor of A11. Similarly, what is the minor of A22? This minus 3. So leave this row and this column. It is 8 3 minus 2 1. 8 3 8 3 minus 2 1. This is the minor of A22 or minus 3. Similarly, what is the minor of A33 or 1? We have to leave this row and this columns. 8 4 minus 8 minus 3. 8 4 minus 8 minus 3. If we simplify it, what we are getting? Minus 3 into 1 minus 4 into minus 2 plus 8 into 1 minus of minus 2 is plus minus 2 plus 8 into 1 and then 8 into minus 3, 8 into minus 3 minus 4 into minus 8. If we multiply this, minus 3 into 1 is minus 3, minus of minus 4 into minus 2, which is equal to plus minus 8, because minus comes 1, 2, 3 times, and plus 8 plus 6 minus 24 and plus 32. If we simplify, minus 8 plus 8 is cancelled. Minus 3 minus 24 is minus 27. Minus 27 plus 32 is 5. 5 plus 6 is 11. This is the value of S2. Similarly, if we find out the determinant of A, it is nothing but 8 multiplied by minus 3 plus minus 6, minus 8, sorry. So we can write down in the step by step 8 into minus 3 into 1 minus 4 into minus 2 minus of minus 8, this one, which is equal to leave this row and this column and this row, 4 into 1 minus 3 into minus 2 minus 2 multiplied by minus 2 multiplied by, leave this row and this column. 4 into minus 4 is minus this, 4 into minus 4 minus of 3 into minus 3. So if we write down 8 into minus 3 minus 8, minus of minus 8 is plus 8. Let me write down. 4 plus 6 and minus 2, this is minus 2. 4 in minus 4 into 4 is minus 16, and minus 3 into minus 3 is 9. If you simplify 8 into minus 11, minus minus plus 8, 4 plus 6 is 10, 2 into minus 16 plus 7, 9 is minus 7. 8 into minus 11 is minus 88, 8 into 10 is 80, minus 2 into minus 7 is 14. Minus 88 plus 80 is minus 8, minus 8 plus 14, which is equal to plus 6. Putting the values of S1, S2 and determinant of A in the given equation 1, then what is S1? S1 is nothing but 6, S2 is 11, and determinant of A is equal to 6. So these are the values of S1, S2 and determinant of A. If we put these values in the given equation number 1, we have the characteristic equation of the given matrix. Now, our aim is to find out the values of lambda. Since the power of this equation is 3, or it is cubic equation, so we obtain the three values of lambda, and that values of lambda will be the eigenvalues of this matrix. So let us try to simplify it. We can also use the calculator to find out the solution of cubic equation in one shot, or let us try to rearrange the term by using the factorization method. We are also able to solve this question with the help of factorization method. The first thing, we have to first take that we have to first use the heat and trial method, in which we have to put the value of different values of lambda and in the given equation. If that values or lambda will satisfy this equation, then we say that that value of lambda will be the root of the given equation. Okay, let me just put that lambda equal to 1. If you put lambda equal to 1 in the left hand side, what will happen? 1 minus 6 plus 11 minus 6. So minus 6 minus 6 is minus 12. 11 plus 1 is 12, which is plus 12. So it means that lambda equal to 1 is the root of this cubic equation. So let us try to adjust the term so that lambda equal to 1 can be taken as a common from the given equation. So now what we have done over here, lambda cube, we have written lambda cube as it is, no change over here. Now if you want to find out the lambda minus 1, so we have to write down this lambda times of lambda minus 1, or lambda cube, lambda square into lambda minus 1. So this is, if you multiply it, it is lambda cube minus lambda square. So we are trying to factorize factorize this 6 into two parts. The first one is the minus 1 and the second one is the minus 5. So minus 1 minus 5, which is equal to minus 6 lambda square. Now this is minus 6 lambda square, it is plus 11. I want it should be lambda minus 1, so minus 5 lambda square plus 5 lambda if we write down. So from this part we also get, if we take 5 lambda outside, lambda minus 1 will be taken outside, will be remaining over here. So here we have 11 lambda is break down into two parts. First is the 5 lambda and second one is the 6 lambda, and at the last part it is already minus 6. So if we take 6 outside from this two part, we are getting lambda minus 1. Now if we write down like that, lambda cube minus lambda square minus 5 lambda square plus 5 lambda plus 6 lambda minus 6 equal to 0. So we have made a pairs. Now from the first pair, if we take lambda square common, what is remaining in the bracket, it is lambda minus 1. If we take 5 lambda outside from this two part, we are getting here lambda is remaining, here 1 is remaining. Since we have taken minus sign over here, it should be minus, not plus. Just a minute. This is minus, not plus, because we have taken minus sign outside. So minus, and from the last part, if we take 6 outside, it will become lambda minus 1. So we have taken lambda minus 1, lambda minus 1, lambda minus 1 common. What is the remaining in the first part? It is lambda square minus 5 lambda and plus 6, which is equal to 0. Now, this is again quadratic equation. We will try to factorize this quadratic equation in this manner. Lambda minus 1. Now, what is the multiplication of 1 into 6, which is equal to 6? So this 6 can be break down in such a way that the addition of the factor of this 6 will be 5. So 6 can be written as 1 into 6. It can be also written as 2 into 3. Only there are two possibilities. Since here minus 5 is over here, since it is minus sign, so both the value will be negative. So if we take the first root, 1 to 6 equal to 6, if we take minus 6 lambda minus lambda, it will become 7 lambda, minus 7 lambda. But it is minus 5 lambda, so instead of taking these factors, we will take 2 and 3. Right? So if we take both as a negative, minus 3 lambda minus 2 lambda, then it is minus 5 lambda plus 6. Again, if we take lambda minus lambda square minus 3 lambda is the first part. If we take minus outside, minus 2 lambda minus 6 equal to 0. If we take lambda outside from this part, remaining is lambda minus 3. If we take 2 outside from the second part, we get lambda minus 3 inside the bracket. So now, again lambda minus 3 can be taken outside. We have lambda minus 1, lambda minus 3 we have taken outside. What is the remaining in the inside the bracket? Lambda minus 2, which is equal to 0. If we simplify it, lambda equal to 1, 2, and 3. These are the eigenvalues of the given matrix. Now, now let us first check that our answer is correct or not. The first thing is, what is the sum of these eigenvalues? So 1 plus 2 plus 3, which is equal to 6, and it is nothing but the sum of diagonal elements, right? If you multiply this 1 into 2 into 3, which is equal to 6, which is nothing but the determinant of A. So in this way, we are able to clarify, or we can verify the answer of eigenvalues are correct or not. If at least any one of the two condition will false, then definitely that will not be the eigenvalues. And what it means? It means that we have calculated the eigenvalues of the given matrix in the wrong manner, or there are some calculation mistakes. So we have to again recheck all the steps and try to find out the correct answer. Here, the eigenvalues are 1, 2, and 3. Now we want to find out the eigenvector corresponding to lambda equal to 1, lambda equal to 2, and lambda equal to 3. In the examination, sometimes they will not ask all three eigenvalues. They will ask about find out the eigenvector corresponding to the smallest eigenvalue. So here, what is the smallest eigenvalue? It is only 1. Sometime they will also ask that find out the eigenvector corresponding to greatest eigenvalue. So here 3 is the greatest eigenvalue. Or sometime it may be also asked that find out the eigenvalues of the given matrix and find any eigenvector corresponding to any eigenvalue. So there may be some different ways to ask the eigenvectors. Either they will ask all eigenvector corresponding to lambda equal to 1, lambda equal to 2, and lambda equal to 3, or they can only ask one question It also depends what is the weightage of the question. Suppose the question is of 4 marks or 5 marks, they will only ask about the one eigenvector. But if the question is more than 5 marks, means 6 or 7 marks, then they will ask about the all three eigenvectors. Now we have to find the eigenvectors corresponding to eigenvalues lambda equal to 1. Let us take the first one, eigenvector corresponding to eigenvalue lambda equal to 1. Let x1, which is equal to column vector x1, x2, x3 whole to the power, means whole transpose. It means that it is a column vector, not the row vector. Be eigenvector corresponding to eigenvalue lambda is equal to 1. Then the characteristic equation of a matrix A is given by A minus lambda Ix, which is equal to 0. What is A? A is nothing but 8 minus 8 minus 2, 4 minus 3 minus 2, and 3 minus 4, 1 minus lambda, and I is nothing but the identity matrix of order 3, x1, x2, x3, which is equal to 0, 0, and 0. This can be also written as, we are not changing anything over here, the first matrix. We have to just multiply lambda to the second matrix. So this is lambda, and this is lambda, rest will be 0 of x1, x2, x3, which is equal to 0, 0, 0. Now 8 minus lambda, 8 minus lambda, minus 3 minus lambda, and 1 minus lambda. This 3 will be changed and the remaining part will be as it is. Just look here. This is minus 8, minus 2, no change over here. 4 minus 2, no change. And 3 minus 4, this will not change. Only the changing in the diagonal element. First one is 8 minus lambda. Second one is the minus 3 minus lambda. This is 8 minus lambda, minus 3 minus lambda, and 1 minus lambda. Putting lambda equal to 1 in equation number 3. So if you put lambda equal to 1 over here 1, and here 1, what will happen? Let us take in the next step. 8 minus 1 is 7, minus 8 minus 2. This minus 3 minus 1 is minus 4, and 1 minus 1 is 0. Rest will be the same. Now let us write down all these things into the form of equation. How to write it? Very simple. 7x1 minus 8x2 minus 2x3, which is equal to 0. Similarly, second equation, 4x1 minus 4x2 minus 2x3, which is equal to 0. Third equation, 3x1 minus 4x2 plus 0x3, which is equal to 0. So this is system of homogeneous linear equations. There are 3 equations and variables are 3. So we can check that this equation has trivial solution or non-trivial solution. Because if we say about the trivial solution, means all x1, x2, x3 will be 0, which is not possible in case of eigenvectors. So now here, all time, if you want to solve or simplify this equation, we always get the non-trivial solution. So to find out the non-trivial solution over here, we can use the matrix method, or we can also use the Cramer rule. So let me use the Cramer rule. In this rule, we can only take the 2 equations. Either we can take these 2 equations, or we can take these 2 equations, or we can take these 2 equations. So there are 3 equations. So we have the 3 options. Either we can take 4 and 5, 4 and 5, are 5 and 6 are 4 and 6. If we take any two equations, even though we are taking the different equations, but the answer will be same. So here we are using the first two equation, 4 and 5, 7x1 minus 8x2 minus 2x3, and 4x1 minus 4x2 minus 2x3 equal to 0. Now, how to solve by using the Kramer rule? This is very important. Let us take it how to solve it. So we have to write down the first x1. How many variables were here? Three variables, x1, x2, x3. So we have to write down x1, x2, and x3. Below the x1, well, let us leave this part. So what is remaining? We have minus 8x2 minus 2x3 minus 4x2 minus 2x3. So we have to just write down the coefficient of x2 and x3, which is minus 8. Just look here, it is minus 8 and it is minus 2. Similarly, what is the coefficient of x2 and x3 in the second equation? Minus 4 and minus 2. Just look here. So this is what it is, the first term x1 upon determinant of the coefficient matrix of x2 and x3. Now, which is equal to, we have written minus sign. Why we have written minus sign? I will discuss about it. Let us first look here. Again, we have to leave the x2 and we have to write down what is the minus 2 and then 7 4. But here we have written, just look here, it should be like that, minus 2 7 4. But here we have written this determinant first 7 4 and then minus 2. That's why we have written the minus sign in the numerator. Why it is written? Because we have to start from this steps, but we are starting from this step. So that's why the minus sign came over here. Hence, so we have 7 4, the first, this matrix, first column, and the second column is minus 2 is in the second column, which is equal to x3. If we take upon x3, what is that? 7 4 and minus 8 minus 4. This is very simple. 7 4 minus 8 minus 4. Now, if we simplify it, x1 upon minus 8 into minus 2, minus 4 into minus of minus 4 into minus 2. Similarly, minus x2 upon 7 into minus 2, minus of 4 into minus 2, and x3 upon 7 into minus 4, minus 4 into minus 8. So if we simplify it, x1 upon 8 to the 16, and it is 8, 16 minus 8, minus x2 upon minus 14, because this is what? 7 to the minus 14 minus 8, minus minus it become plus, which is equal to x3 upon 7 into 4 minus 28, and 4 into minus 8, minus 4 into minus 8 is 32. If we again simplify it, 16 minus 8 is equal to 8, minus minus we minus x2 upon minus 14 plus 8 is minus 6, and x3 upon 4. So this minus and minus will again cancel. And if we multiply whole equation by 2, then we have x1 upon 4, which is equal to x2 upon 3, which is equal to x3 upon 2. Let us consider this is as k. So what is the value of x1? X1 is nothing but 4k, x2 is nothing but 3k, and x3 is nothing but 2k. So these are the values of x1, x2, x3. So therefore, the eigenvector corresponding to the eigenvalue lambda equal to 1 is given by x1 is equal to 4k, 3k, 2k transpose, or which can be written as, if we take k outside, the minimum least common factor. So 4, 3, 2 to the power transpose of the 4, 3, 2, or it is the nothing but the column vector. So this x1 is the eigenvector corresponding to lambda equal to 1. Similarly, we are also able to get the eigenvector corresponding to lambda equal to 2. So let x2 is equal to y1, y2, y3 transpose be eigenvector corresponding to eigenvalue lambda equal to 2. Putting lambda equal to 2 in 3, we have 8 minus lambda is 8 minus 2, minus 3 minus lambda is minus 3 minus 2, and 1 minus lambda is 1 minus 2. In the same manner, we can simplify it. 8 minus 2 is 6, minus 3 minus 2 is minus 5, and minus 1 minus 2, 1 minus 2 is 1, minus 1. If we write down in terms of equations, 6y1 minus 8y2 minus 2y3, just we are multiplying in this previous example, this into this plus this. Similarly, we can write down 4y1 minus 5y2 minus 2y3, which is equal to 0. And the third equation is 3y1 minus 4y2 minus minus y3. Now again, we have already seen that this is the system of homogeneous equation, and here we always get the non-trivial solution. So we can take again any two equations, either first two or last two or first and last. We are independent. So let me take the first two equations, 6y1 minus 7 and 8. We are taking the first two equations, this and this. Again, we have to leave this part, y1 upon minus 8 minus 5 minus 2 minus 2, which is equal to, let us take the second part. So 6, 4 and minus 2 minus 2, and that's why we have taken minus sign over here. And if we take the third one, this one, y3 upon 6, 4 minus 8 and minus 5. Again, if we simplify, minus 8 into minus 2 is plus 16. Plus 16 minus 10 here, minus 12 plus 8, and the last one minus 30 plus 32. If you simplify it, what we are getting? 16 minus 10 is 6, minus 12 plus 8 is minus 4, and minus 30 plus 32 is 2. So it gives y1, if we multiply whole equation by 2, y1 upon 3, this minus minus will cancel, y2 upon 2 and y3 upon 1. Let us say this is equal to k. So y1 is equal to 3k, y2 is equal to 2k, and y3 equal to 1k. Therefore, the eigenvector corresponding to eigenvalue lambda equal to 2 is given by x2 is equal to 3, 2, 1 transpose. This is what it is, the eigenvector corresponding to lambda is equal to 3. Similarly, we are able to also get what is the eigenvector corresponding to lambda equal to 3. Same process we repeat over here, and ultimately we are getting the three equations. Out of these three equations, we are able to take the any two equations. So let us take the first 10 and 11 equations. We have the same cases here, minus 8 minus 6 minus 2 minus 2 equal to minus z2 minus z2. If we take that one, so leave this row and this column. So 4 minus 2, we are taking only the first two equations, right? Okay. So here if we leave this part, so 5, 4 minus 2, 2. If we leave the first one, this one. So minus 8, minus 6, minus 2, minus 2. For the second case, we have to leave this part. So 5, 4, minus 2, minus 2. And for Z3, it is 5, 4, minus 8, minus 6. If we simplify it, the simplification is very simple and we are able to get this answer. Z1 upon 4, Z2 minus Z2 upon minus 2, Z3 upon 2. If you multiply whole equation by 2, so the value of Z1 is 2k, value of Z2 is k, and value of Z3 is equal to also k. Therefore, the eigenvector corresponding to eigenvalue lambda is equal to 2 is given by x2 equal to 2, 1, 1 transpose. Hence, the eigenvalues and eigenvectors of the matrix A are given by lambda 1 equal to, if lambda 1 is equal to 1, x1 is this. If lambda 2 is equal to 2, x2 is 3, 2, 1. And if lambda 3 equal to 3, x3 is 2, 1, 1. So these are the eigenvalues and eigenvectors of the given matrix. Thank you.